Alright, so in this lesson here today, what we're going to do is we're going to talk about the C programming language. Now, we are going to only very briefly talk about this because a couple lessons worth, because you should all be familiar with C programming. You should have had a course in C or C++. The device we're going to be using and the application interface for it uses C programming language to do everything. So the first thing I want to review here are things like data types. So for example here, we may have a variable, and let's just called data1. But C requires us to define what type of data is stored in data1. Now there are a lot of different data types. I mean, there's also arrays and other things of that nature. I'm not going to go into all of those details, and the reason I'm not going to go into those details is that we're going to use predominantly just a few different types of data types. So the most common ones we're going to use are integers, signed / unsigned. We're also going to do floats, which you can think of these, I mean, those are floating point decimal numbers, so decimals. Character, now these are usually just character arrays. Now these aren't the same thing as strings. Strings are different than character arrays, but this is where we're going to contain like character data, like if we're wanting to display the, something on an LCD screen, that's where we would contain the text that we're going to be displaying on there. And then you might use, I honestly don't use them too often, just because I don't find the need for them, is a Boolean. Now, I want to talk a little bit more in detail about some of these data types here, specifically integers. Now, we know if we want to declare a variable, that we would do something like, for instance, for an integer, we would do int data1 semicolon, and then that basically is that we'd have declared a variable data1 of type integer. And then depending on what kind of programming language you're using, we would be able to if it's a 32-bit or 64-bit, determines the size of the integer that you're going to be able to store inside there. Now, this automatically assumes that this is assigned data. Now, one thing you can do here is you can do something that's called uint data1, and of course, obviously, ending them with semicolons. Here, I'm going to just do this here. Let's decrease this width just so I have a couple colors. This is an unsigned integer. Now, to understand the difference between them, let's first just go through an example here between signed and unsigned. And let's look at 8-bit integers. And the reason we're going to do 8-bit integers, actually, let's even go lower than that. Let's do a 4-bit integer. There's no need to go to 8 bits. You can do the same thing in 4 bits here. So if we have 4 bits, we have bit 3, bit 2, bit 1, and bit 0. Okay, so this, if it's just a regular integer, so we've declared this as int data1, and again we're using a 4-bit integer in this case, well then this first bit here, this is what we call the sign bit. And this is either a 0 or 1. And 0 is positive, 1 is negative. So that tells me whether I'm dealing with a positive or negative integer. Well then, that also means that I've got these remaining bits to be able to determine what the number is. So if I look at this here, I can do, for instance, this would be, what I'm trying to say, these 3 bits would be for the actual value of number. So that's the value of the number. So if we look at an example here, for instance, if we had something that data1, and I'm going to just put it here that the bits were 1, 0, 1, 1. If that's what was stored in data1, well, this gives me negative, and then this here would be 3. So data1 is equal to negative 3. Now when we do that with a signed or an unsigned bit, what we have here is we have a limited number of things that we can put in. Because if you think about, if I want to look at the largest positive number I could put in, largest positive number that I could put in would be 1, 1, 1, 1. And so this would correspond, I'm sorry, not 1, 1, 1, 0, 1, 1, because 0 means it's positive, and then I've got 3 1s, which actually gives me positive 7 as the largest value being able to be stored. Now, if you think about this, you might say, oh, well, then the smallest data that could be stored would be negative 7. But actually, you can get all the way down to negative 8 without explaining the differences on how you can get to that. You can get all the way down to negative 8. Just because we don't have to have, if you think about it here, if I do 0, 0, 0, 0, that's equal to, quote, positive 0. And then 1, 0, 0, 0 would be like, oh, well, wait, that would be negative 0. Huh? Negative 0 and positive 0? We know that doesn't make sense. There's just 0. So what you can do here is you can say that this is 0. And then you can say that this corresponds to negative 8. So if you have the sign bit there and all zeros, you might say, well, that doesn't add up to negative 8. Well, you think about this here would be an 8, and we don't need negative 0, so that would just be assigned negative 8. So for a 4-bit integer, it can only store values from negative 8 to 7. So if you tried to store (15) in data 1, we would have what's called an overflow error. We're trying to put too big of a number in there. Now the difficulty with this is oftentimes the C code will still compile and run, but you're going to get weird effects because you're actually not able to determine. It will store data in there, it'll still store a number there, but it won't ever interpret it as 15 because we're using a signed integer, just a regular 4-bit integer. Now, this is where you can get larger positive integers without actually having to have larger bit sizes. Because instead, if we did here a 4-bit unsigned int, so we did uint, well then unsigned always positive. So there's no way to store a negative number in an unsigned integer. But the key thing here is I can store a positive one, which, hey, that's great, so I can store positive. So if I have a 4-bit, here I'd have bit 3, bit 2, bit 1, bit 0. But this all is data, or value of number. So if I look at this, well, the largest number is simply 1111, which is 15. And the smallest number is 0000, which of course is 0. Now, one thing I want to point out here between these two things here is, look here, we got -8 to 7 and 0 to 15. So this is for an unsigned, and then -8 to 7 for an int. But notice in both cases there are 16 values. And that's because it's a 4-bit integer. And an easy way to determine, wait an hour, I don't want to restart. The easiest way to determine whether something is the maximum or largest value here is if we can say largest value for unsigned, we'll do the unsigned because those are easiest first. For unsigned is just 2 to the n minus 1. And so if you had an 8-bit, that would be 2 to the n, 2 to the 8th minus 1, which 2 to the 8th would be 256, I believe, last time I checked, so 255. And then the smallest for an unsigned is always 0. Now, if we did a signed one, the largest is 2 to the n minus 1 minus 1. Because remember, we're losing 1 bit to the sorry, lost my train of thought, because the first bit is being used as a signed bit. So if we did this again, we'd have 2 to the 8 minus 1 minus 1, sorry, 8 minus 1 and the exponent minus 1. And that would give me, 127. My brain's not working with math right now. Now the smallest is simply just -2 to the n minus 1. So this would be -2 to the 7th power, which is -128. Now, you might say this isn't that big a deal, but it becomes a bigger deal because when you're programming on embedded systems, we have a limited amount of memory. Now, in most cases, we don't have to worry about memory. There's plenty available, but sometimes it is you have a limited amount of memory available and your programs are large enough that you need to make sure your datas are essentially as small as they can be. So, for instance, if I know the data I receive is from 0 to, let's say, 165. Well, I can only go in, the standard ones are 8-bit, I'm sorry, 4-bit, 8-bit, 16-bit, so on and so on. Well, 0 to 165, that is clearly always positive, so I could use an unsigned int, and then I'd have to figure out how many bits I would need. Well, 8 bits wouldn't be enough, or I'm sorry, 8 bits would be enough, because that goes up to 255. 4 bits wouldn't be enough, because that just goes to 15. So you go up to the next one, which goes 8 bits, which goes up to 255. So this would have to be, at minimum, an 8-bit integer, or uint, sorry, unsigned integer. Now, you could do an 8-bit integer, but if you did an 8-bit integer, not big enough. And why is it not big enough? Because an 8-bit signed integer only goes up to 127. So, well, this isn't going to be super critical in the course. This is something we absolutely need to be aware of when we start getting into embedded systems, is making sure we don't run into overflow errors like this.